This is my 6502 based breadboard computer. I like the 6502 quite a lot because it runs code in mostly single cycles, so it's very efficient. Unfortunately, because the instruction set is so simple, it can't, it's quite difficult to do complex maths with it. So I thought what a good idea would be is to include some sort of maths coprocessor, and that sounds quite complicated and difficult to do, but I thought I'd come up with a simple solution. So what I've got at the moment is an 8 megahertz crystal running a 6502, and it's got 32k RAM, 16k ROM. It's a flash ROM. I'm only using 16k of it, and this is a 6522 that's talking to a USB, so can run the terminal emulator. I have a gal here to do the decoding for all the chips, and that's just a NAND gates that are used for the read and write signals that we need to use. But the extra part, that's all quite standard, but the extra part I did was these chips here. Now what I've got here, I've got some D-type flip-flops I call A and B, and that's a big ROM. That's 39SF040 ROM chip, so that's got 19 address lines. So what you can do is you can put two numbers in the two 8-bit D-type flip-flops, and then you've got 3 address pins left over, which you can then use to address the ROM for any mathematical instructions you want to put in the ROM, and then read it back into the processor, into memory, and use in your program. So that's the basic idea, and I shall show you a demonstration with a Mandelbrot set. Yeah, I'm running a pretty standard Wasmon on my 6502 breadboard computer. So I can use Teraterm to send some files. So that's a Mandelbrot, and this is the Mandelbrot that uses the ROM as a coprocessor. So if I run the first one, which is basically Matt Heffernan's implementation of hardly any changes, and it just prints out as ASCII characters rather than colored squares, and that takes about 2.5 seconds at 8 megahertz, which is pretty good. I'm quite happy with that. But if we use the mass coprocessor, you can see if I run now, that's quite a bit faster, and that works out to be about 3/4 seconds, 0.75 seconds. So that is quite a huge improvement. So let's just see what happens and how it works. So to put data into the coprocessor, you use address 10 or 10 in hex, and I can put a number in there like this will be in hex, so a number like 7, for instance. Is write only, so that will always come back as 0. It doesn't, there's no RAM shadowing it. And the other, what I call the B register, would be 18. So let's put, I know 5 in there. So I've now loaded A and B with a number each, and to find out what the coprocessor does, we'll print out everything from 0 to 7, address 7, and that's where the ROM is map to. So as you can see, the first number is 2300 because doing a multiply of two 8-bit numbers, you get a 16-bit number. Now, if you let's put it into programmer in hex. We do 7 times 5. We get 23. That'll be 0023. So that's the two numbers multiplied together. The second two numbers, the first number is the remainder when you divide 7 by 5. So 7 divided by 5 is 1, remainder 2. So that's the remainder 2, and that's the 1, which is the result of the division. And then these last 4 numbers here, this is actually taking the number 0507 as a 16-bit number and then squaring it, and that produces a 32-bit number. Now, I'll just prove that by going, I think it's 0705. If I multiply them together, we get 00, doesn't show it, 00, 31, 46, and 19. So what's happened is that at address 10, it's mapped to the A register. At address 18, so these are in the 0 page, so that it speeds up quite a bit because you're only using 1 byte for the address. You could, of course, map to other addresses out of the 0 page, but it would take longer to load both the A and the B register and then get a result as well. So I've mapped the results to 0 to 7. Now, if I used a bigger ROM, in fact, I've got a bigger ROM. I've got a 27C 322, which are obsolete now, but you can still buy them if you look around. And that they're 32 megabit, and you could actually get 64 different results out of that chip because it's 16 bits wide, and you have an extra 5 bits of for the different functions that you can have. So that gives you 32 functions, but as you get it's got a 16-bit output, you could then either take the higher byte or the lower byte, give you 64. So you could have all sorts of things like logarithms and sines, cosines, trigonometry, anything you could think of, square roots, things like that. So that's basically what I wanted to say about using a mass coprocessor, a very simple one. And yeah, that's it. Thanks.